Hello everyone. Today I'm discuss one another thing in in terms of AI only. It is improving zero shot learning in multimodal environment. So particularly for languages and tasks, zero shot learning is to generalize unseen classes during inferences, but its current effectiveness is limited in complex real-world multimodal settings, such as integrating text with dynamic video content or cross domain datasets. So the problem is important because multimodal AI systems such as conversational agents or autonomous vehicle must handle interactions and scenarios not covered during training. Addressing GSL in this context can enable AI to better understand and respond to novel situations. So I think that zero shot learning, multimodal AI, uh, and understanding of this has has some understanding of data sets and interaction of data sets to determine the variability of data sets uh, and variability of unlabeled data set or labeled data set, right? So uh, so when we talk about zero shot learning, it's a machine learning technique that allows models to recognize and classify new concept without labeled example. So what happens in zero shot learning is naturally what happens that in supervised learning there is a labeled example. In unsupervised learning there is no label example. Label are predicted by unsupervised pattern of understanding supervised patterns. I mean, naturally what happens that the pattern can form within the sphere of supervised learning. So naturally it forms in that this way, right? That we understand the pattern of any of the classes in particular data sets. Uh, so I mean, in zero shot learning, what I see that machine learning technique that allows model to recognize and classify new classes concept without labeled example. Okay, so it is like pre-trained model on large and diverse set of data such as images and text. Describe the new present new classes to the model using natural language description or emitting vector. Okay, so I mean, there are a lot of domains. Computer vision, NLP, and healthcare is the one. Just there is a versatile, useful, yeah, small problems associated with that. Okay, so it's a machine learning scenario in which AI model trained uh, uh, trained so AI, I mean AI model trained to recognize and categorize objects or concept without having an example of this category concept beforehand. So naturally what happens that the pattern forms. I mean, naturally what happens that when I understand that this object is this object is that, or that is object is something that, right? So naturally what happens that we form the patterns of understanding that and try to interrupt that particular patterns in understanding that particular object. So natural weight and biases to understand particular model, it can be developed by that insight. So zero shot learning in this regard is this one only, that is a machine learning technique that allow model to recognize and classify new concepts without labeled example. So naturally we have a labeled example of anything and everything. When we understand the objects or without understanding object also, we will, I mean, we naturally in supervised learning we have a labeled example and we can understand that labeled example to supervise our models. Okay, but in unsupervised learning, it is naturally that models can form patterns by themselves and predict the next word, next objects, or next image, or next transcript or anything. I mean, this is how it can be done by zero shot learning. Okay, so I mean, uh, there are various applications. I've already told you that in LLP we tried to break the sentences work, sentences text, and next token. In computer vision, we have this understanding of predicting next objects and what next object will be, right? So this is how it can be, right? GSL also used in healthcare, so where we need to determine. I mean, maybe the medicine or maybe right kind of medicine that can be used so that we can treat the patients, or maybe zero shot learning helps in develop that intuitiveness within the model without determining the necessary supervised learning concepts where we have a labeled example. But in zero shot learning we have this assumption or intuitive assumptions to predict the next word, next token, or next understanding of the things, right? So what's the difference between that? Simply that uses semantic embeddings and external knowledge base to classify unseen categories like data scarcity, generalization, scalability, and overfitting. So it uses a semantic embeddings, right? So it is a method that utilizes pre-trained word embedding to place original words in sentence with closest neighbors in embedding. So naturally what happens that uh, uh, and enhancing naturally what happens that when you replace that particular original words which are closest to closest neighbors to the same words, then what we can do is we can understand and we can see that there is a creation of pre-trained word describe pre-trained word and representation of semantic meaning in natural language processing tasks. So, cementing words are measuring similarity between two texts, while search cementing better finding long texts that are relevant to short queries. Simply, what happened? The semantic embeddings is providing relationship between two texts in understanding two texts and through determining the variability and visibility of two texts. So, zero shot learning uses that. Okay. So, natural understanding of zero shot learning is observe a learner observes samples from classes which are not observed during training and needs to break the class that belong to. Okay, so from in the training we haven't checked those classes, but in which was not observed during training. They need to break the class that they belong to, right? So where a test timer observes samples from classes which are not observed. Okay, so this is how uh, zero shot learning can be used in computer vision and natural language processing. Okay, so for few shot learning we have task specific data. Okay, perform the task. For zero shot learning it is not. Okay, JSL models are supervised methods that are effectively trained, but they are able to export knowledge beyond the basic training data set. Okay, so so that is how it is. Why it is called zero shot learning? Because complete tasks without having received any training example. Consider the case of recognizing category of object in images without ever seen a photo of that particular object. So it is zero shot learning, right? So this is how uh, zero shot learning is. Okay, what it uses is pre-trained knowledge to interfere the correction between the new classes description and its learned feature space. So describing the new classes to model using natural language description or embedding vector, pre-train the model on large diverse set of data such as image or text. So we are doing that, and how to cement embeddings are one thing I've already told you, and other than that, it is like uh, how we can you know control the overfitting and underfitting. Overfitting, to few examples provided. One of the important challenges in future zero shot learning is a domain shift problem. Instead of seen and class and unseen classes, the domain shift is large. The model may fail to accurate prediction about unseen class. So naturally, what happens that there are a lot of domains in particular classes, or maybe there are a lot of classes in particular domains, and vice versa. So it can be happens that there may be some mixing of domains and uh, mixing of domains and mixing of interlinked domains. So it is very highly sometimes it is very inaccurate to predict prediction about the unseen classes, right? So I think that is zero shot learning. Okay. uh, Without saying any objects we can determine particular object, right? So it is few shot and zero shot learning. Okay. So I think when this is one understanding of zero shot learning, right? When I understand anything, direction, early direction, but knowing ensemble methods to reduce the model's tendency to overfit the specific patterns, identify and retain only the most important feature of the model. So I think this is how it is. Overfitting can only be detected during the training phases, testing phases. K-fold registration, which allows spin data into subset and one subset for testing. So what happened? That naturally what happens that we divide the particular data set into training or testing cases. So uh, one way is to use to have k-fold cross validation, which involves splitting data into subsets and using one subset for testing. So we trying to split that particular data into subsets and using any more subset of the testing. So naturally is we have a k value of 3. Okay, determining uh, the offset of 1 and 2 data set, or maybe 2 to more data set, then we can divide that particular thing. Okay. So what overfitting is essentially means is naturally that we don't have optimized way to classify that particular objects or thing, right? So we have a loss functions also. We have that validation set. Okay. uh, why we have that validation set which which can which can improve that particular thing, that some sets are there. So when I see about understanding of validation set, so I think that I mean the validation that uses robust to training data to provide an unbiased evaluation of model. It contrasts the training that it's an intermediate phase used for choosing the best model optimizing. Simply what happens that we have a dimension of doing this thing, that training phase, testing phase, and validation phase. That where the optimization task is about to happen, and it is an in between the stage where we're trying to predict tokens or maybe anything. It's a validation test, mixing of uh, when we think about model. So 80-20 is the ratio. Then in between that we do this. Okay. So data check for validity of data. Okay. So um, make sure the data is clean and accurate, and so validation is checking validity of data. Okay. Unbiased evaluation of model performance to fine tune the model parameters. The test on other end is used to model has been trained to success. Okay. So simple thing is in validation stage we try to fine tune the particular training data to get the finest of test set. Okay. So this can be done. Okay. This can usually be done. Okay, in understanding data and interpreting data. Okay. So this is a common understanding of zero shot learning. Okay. So the enable model to recognize a label instance which has never occurred during training. Okay. uh, the model is trained on a set of classes with associate attribute and textual descriptions, image classification, NLP, and robotics, domain shift, semantic gaps, and noisy attribute. Challenges are domain shift, semantic gap. Semantic information is crucial, so there is a gap of semantics. So then again, there is a problem. Multimodal learning. Uh, develop methods to take JSL models to more resilient to noise and variability in data. Combining zero shot and future learning to handle scenario with limited labeled data for some classes. Okay. So So other than that, it is model to recognize and classify instance from categories that we are not present during training, that were not present during its training phase. This is particularly useful in scenario where acquiring labeled data for every possible category is imperative and impossible. So naturally, what happens that why it's called zero shot learning, because the variability of classes and categories are n numbered. So naturally it is very hard to recognize and doing the things. So it is tough. I mean, tough to understand. So naturally, we have unseen classes. Okay. So between class and attributes. Okay. So it is again a zero shot learning and understanding of zero shot learning in contextual text, in speech recognition, recommendation system, and in image recognition also we have a same attribute and embedding spaces. Okay, we have a genetic model, a genetic understanding of this. Class imbalance is the main problem. Domain shift is the main problem. Attribute correlation is the problem. Naturally, what happens that if we have a class which is like a dog or a dog of two types, they have same attribute or different attribute, then we have a imbalance over that. So this is how it can be. So we have mathematical proof also. So we have a classes, we have a training set, right? We have a test set. Okay, we have a feature from like x x you can have variable. Functions is vector attribute, semantic attribute. We have function x is belong to a attribute space. Learning is j is x s belong to a, and for yeah, for something which is not seen is g of x. Okay, xj. Okay, generalization bound is diversity p. Yj, predicted output is not an actual output, belong to E. So lens of feature representation, we can see that zero shot learning. Okay. So we have discussed when we discuss PCA and clustering and everything, we have discussed supervised, unsupervised, semi-supervised, and reinforcement learning. I have already have a video on reinforcement learning and understanding of reinforcement learning. So today I have discussed zero shot learning in this video. Okay. So this is that this is this the this is now enough for that particular video. Okay, so thank you so much everyone.